will be. That's all there is to it. So I'm saying, if you feel badly about this exam, feel bad about it, start acting now to learn that which you didn't know. Because we're going to keep learning. You won't have time after today to even think about it when you're doing too much more stuff. Okay, now we talked about, and by all means, the TAs are there and I am here. I'm here before the class. You've got a problem, you've got any issue on that exam you didn't understand, the next class you'll be here at 5 o'clock and you ask me. And we get it together, we move ahead, right? You do not want to have weak foundation in first year. Learn to learn and be good at it, and everything will be cool. I found with lots of students and some extraordinarily smart students, they didn't actually know how to learn. They didn't know how to study, they didn't know how to lean into it, they didn't know how to really put some effort into it. They came to first year and they got blown away, right? And they could be doing anything. They might have gone into physics or chemistry or whatever. Poli-sci, psychiatry doesn't mean, or psychology, doesn't really matter. Eventually, sometime in their school time, they learn to study and to be serious. Doesn't matter what you do. You can start with psychology. Once you learn to be serious, and you're a student, you get B's and A's, you can do anything. You can do physics, you can do math, you can do anything. But you must learn that ability. That's huge, right? And until you learn that, you aren't going anywhere. So please, as I say, the sooner you learn to learn, you'll be in good shape. Now, last time we talked about marginal utility, and we got as far as I know to this point. Did we talk about budget lines, budget constraints? I think we did. Huh? Yes? I love it. I totally love it. Okay, good. Now, today we're going to talk about indifference curves. Your minds are probably pretty well ruined at this moment in time. So we're going to convey the most abstract material this course has for you, indifference curves. We'll get a good understanding of them in this hour. We're definitely going to stop at 8:30. I'm not asking you to do more than that. The next day we're going to put it all together, right? So again, like everything, you need to, say if people work out, if you don't, like it's phenomenal. I watch a lot of people working out and they don't know how to do it. They don't know how to find their muscles and their strength. They can't move like that. So it's the same with you. You don't fight it. Just relax, understand the concept, boom, then you're strong, right? Okay, good. So we talked about budget lines. We leave that aside. Ultimately, we're going to put budget lines together with this concept of indifference. Now, the concept of indifference really is based on one very simple idea, which is this. If I said to you, and everybody in this room would probably give me an answer, I'd say, how many oranges would you trade for now? And each of you would probably say to me, well, I'd trade 2 oranges, or half an orange, or 5 oranges, or whatever it is. But that's a mistake. That's a mistake. That's what we want to know. We want to know at any given moment how much of one good you exchange for another. But what we don't realize, usually, all of us, is that that is not a constant. It depends on how many oranges and apples you have. So if you had 500 oranges and 10 apples, you could very conceivably get 50 oranges for an apple, even though you love oranges. And we don't think much of apples. You love oranges. But 500 oranges, you don't need 500 oranges. You can throw away 50 for the pleasure of 1 extra apple. But if you had 30 oranges and 500 apples, you would go, wait a minute, I like oranges, I've got too many apples, I'm not giving up an orange unless I get 100 apples, right? So the first thing is we're interested in the exchange of oranges for apples. How many oranges are exchanged for apples and for an individual? But that depends on the number of oranges and apples they have. So the way we analyze this is we start with, again, what we call commodity states, amounts of Y, amounts of X. And we see all the possible combinations, 500 oranges, 500 apples, 300 oranges, 100 apples, all the possible combinations, and we're going to set up a grid, basically, which shows us which is the preferred to another. Okay? So, this is called preference theory. We do it something like this. You'll see in a minute. And it's very important to note, there is no measurement here. All we want to be able to say is, I prefer this combination to that combination. So although the easiest thing is for me to say to you, which do you prefer, the bar, the movie, or the restaurant? That's really simplistic, but that simplistic idea is what we're about. But ultimately, we can't do that. We have to think about how many restaurants you go to in a month, how many bars you go to in a month, and put all that together. But basically, leaving all that sophistication aside, that's what we're doing. We're just ranking. When I say to you, you prefer to go to the restaurant or the bar, and you say, I prefer to go to the restaurant, you could prefer to go to the restaurant 1,000 times more, or barely more. That is irrelevant. It's a ranking. I prefer this to that. That's all it is. Okay? So, what we get is, I want to know, for example, in a space like this is quantity y, quantity x. Supposing I had here this combination, any individual, like this combination right here, okay, this is, and these are apples and oranges, this would be 100 apples and 10 oranges, and over here is, say 20 apples and 80 oranges, something like that. Now I'm going to ask you, which would you prefer? 20 apples and 80 oranges, or 100 apples and 10 oranges? Now unless we know the individual, or unless the individual is telling us, there's no way that we know, right? We don't know. We need a map to know, right? So basically, it's just, we use word like it's similar to the concept of isobars. We want to get a whole bunch of lines that just establish that which is preferred to that, groups that are preferred to other groups, and demarcate the space. Right? So, for example, here is, I don't know if I can do this. This is, say, Lake Ontario, right there. Okay? Now, in Lake Ontario, we have isobars. The weatherman, this is us up here somewhere, tells us that, in fact, here, right in the middle of the lake today, or somewhere like this, in that area, right here, but on this, it is, let us say, 15 degrees, right there, along that isobar. And another isobar might look like this, say something. And on this isobar, it is 16 degrees. Now look at everybody, think about this for a moment. And I'm trying to get you, you know, a really important thing about learning is to relax into it, right? Don't push it, just relax into it. Feel and understand it. We're not interested in, when they tell you this, nobody's interested in getting in a car and driving around for 16 degrees. Like this could be Bloor West somewhere, and this could be, say, St. Clair Avenue all the way over to here, and then this takes you down. Nobody's doing that. That's not what they're telling us that. They couldn't care less. We're not interested in moving along at 16 degrees. We're interested in the fact that everywhere in here it's between 15 and 16 degrees. That's all we need. This isobar tells us everything on the other side is more than 16 degrees. Everything underneath is less than 16 degrees. So if we give all the isobars 16, 17, 18, 19 degrees, at a glance we can see whether it's warmer in Oakville than it is in, you know, say, Peterborough or something like that. That's what it's about. Right? So our isobars are indifference curves. We're going to find out all the combination of commodities that a person is indifferent to relative to a particular commodity. So for example, I'm going to talk about our apples and oranges. The first thing I'm going to say is we're going to start with 50 oranges and 50 apples. I want to find every combination of oranges and apples that that person is indifferent to relative to 50-50. That they couldn't make up their mind. Not that they prefer or not prefer, but they're indifferent to. Now it turns out 49 and 49 has another indifference function. Because 49 and 49, 50-50, you can't be indifferent to. So we're going to have an infinite number of indifference curves, although we'll only draw one or two in a given moment. And we'll have them stacked up in a certain way. And they will basically give us You know, kind of like, again, be careful with crinkling. It's dangerous in this world. Or like with, altitude maps, showing you altitude. This is going to show us the altitude. Okay, so watch. So, we're going to go back to the basic axioms. And the beauty of this is, as I say, the old Mars utility stuff is pretty intuitive, but essentially it's based on a completely weak and junky foundation. That is, that human beings, that satisfaction, pleasure, pain, all the rest of the stuff really defines human beings. It doesn't. Oh! In the other class, but I should mention this one of the other students says, I know how to draw forward. Well, who would I have? There's people who are voting for Rock Ford. Give me a break. Why? I said, why are they voting for Rock Ford? And the other, this guy came up and said, in our psychology class, blah, 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 which I'll explain in a minute. Now, economists, as the basis of our analysis, and I'm not claiming that economic analysis is perfect, because it definitely is not. It's huge flaws. But we should understand where they come from. Economics assumes that people are rational. They have done so for 100 years. That they are rational. That they always make decisions for what's best for them. No, you there. There's no, please, behind. No crinkling, right? No crunching. The guy who's next to you, I don't care if you rip his arm off. I couldn't care less. Just do it quietly. That's all I care about. I shouldn't even care. I like the sound of ripping, but not crunching, right? Okay, because this is not happening to me. Okay, good. So now listen. Now where were we? We were on the issue of economists assume rationality. Everybody makes a choice that is rationally best for them. And that's also the whole pleasure, pain, satisfaction. I rationally decide to do this. But as this student said to me, well, in psychology, they say we never act rationally, which is actually probably wrong. But we know, one of the things we know from it, Freud and every sense, is people act intuitively, immediately, by custom, because their parents told them a lot of the time. And they only act rationally at other times. People sometimes, when you walk in, you're going to have a meal or something like that. A rational thing would be, geez, this is a Big Mac. I shouldn't be eating this piece of junk, right? But actually, I need comfort food, so I eat it. There it is. There's a distinction. So basically, the whole idea that people rationally decide what satisfaction is ridiculous. So you can't base it on that. And also that you could possibly measure the level of your satisfaction is ridiculous. But this doesn't demand that. It only gives you 4 very simple axioms, assumptions. It just says, can you decide about this or that? That's basically it. Not how much, just not because it's good or bad or anything else, it doesn't matter. You prefer this boyfriend over that boyfriend. We don't care if the guy's an axe murderer, it's irrelevant. He beats you, every other nasty thing. You prefer him, that's all. We're not analyzing any deeper than that. So that's what this is all about. The minimum axioms are very important. We're going to look at the axioms, and we're going to build the theory upon those axioms. All right? So here we go. The preference assumptions. I'm just going to use this notation. X1, Y1 means this is the amount of X and Y, and this is another amount of X and Y. Notice I'm always comparing amounts of X and Y to be preferred, rather than what we really want is how much X would you give for Y. But we must analyze bundles of preference, because how much X you give for Y depends on the bundles, right? Okay, so we do that. So this just means I prefer, and this means I'm indifferent to. So I'm just giving you standard notation, but it's pretty simple. The preference assumptions, completeness. For every pair of consumption bundles, anything, any choice, let's make it simple. It should be bundles, but if you ask your friends, do you want to go to the restaurant or do you want to go to the movie? Your friend has only 3 answers. I prefer to go to the movie. I prefer to go to the restaurant, or I can't make up my mind. I'm indifferent. It doesn't matter to me, right? Those are the only 3 options. Now, if you can think of a third or a fourth, you're welcome to it, but that pretty well exhausts it, right? Everything exhausts it. That's a reasonable option. That's a reasonable thing. Now, intriguingly, I'm going to leave that for a moment, But that's the first one. The second one is simply called transitivity. Does anyone know what transitivity of the number line means by any chance? Transitivity of the number line? It's too bad I didn't learn this in grade school. They don't teach it in grade school anymore. It's too bad. Transit, like, you know, when you think numbers, 8 is greater than 6, 6 is greater than 4, therefore 8 is greater than 4. That's called transitivity. And that is an axiom. You can't necessarily, in numbers, you can't just assume that's true. You have to state that. Similarly here, it's a simple thing this. I prefer the restaurant to the bar. I prefer the bar to the movie. Therefore, I prefer the restaurant to the movie. Transitivity. We can set it up like that. I'm indifferent to the restaurant and the bar. I'm indifferent between the bar and the movies. Therefore, I'm indifferent between the restaurant and the movies. Transitivity, right? Now, by the way, the guy wanted to know about prize for proving that in groups you do not have transitivity. Leave that alone. That's very interesting. In groups, that doesn't happen. Okay. So, for example, in groups, if you have people voting just by the by, and you say, we want a highway, we want hospitals, or a highway, or universities, it turns out if they vote for universities over highways, and then they prefer universities over roads, it actually doesn't mean that the one they first rejected is not preferred to the one they ultimately ended up with, because it's not necessarily transitive. But leaving that aside, then we have 3. This one is the one that you might have some doubt about. Non-satiation. More is always preferred to less. You always will prefer more of something to less of something, or the same amount of something plus more of one of the things to something else. Now you might say, well, I don't prefer to have more oranges. At 500 oranges, I don't want more oranges. Well, we'll see you do. You take the oranges and have a bath of oranges, or you do whatever you want with oranges. Now it turns out we can relax this assumption. And at a certain level, it may not be true. But in this course, it is always true. It is always true. It's an axiom. And the fourth axiom is convexity. And all that means is, basically, the more you have of something, the more of it you give away from the other. So basically, if I have 500 oranges and 20 apples, I'll give away 450 oranges to get an apple. If I have 200 oranges and 30 and 70 apples, I'll give away 30 oranges to get an apple. Right? Convexity. Now, those simple assumptions we're going to build on in this fashion. I do it in my notes. Here we go. All right. Right here in the middle is, and I want you to be logical now. This is 50 apples, 50 oranges. Like that. So up here I've got oranges. And down here I have apples. But again, it's not prices, it's just quantities. And the first thing I'm going to ask you is this. Which do you prefer? This is like going to the optometrist. Which is clearer, right? 70 apples and 80 oranges. Which do you prefer? This bundle or this bundle? Tell me, which do you prefer? 70 and 80, why? More is always preferred to less. You cannot be indifferent. If you have more than that, what about this one here? Let's say 50 apples and 80 oranges right there. Can you be indifferent between those two bundles? No, because you have more of one and the same with the other. But 49 apples and 80 oranges, we actually cannot say. Now, it might seem to you obvious that if a person lost 30 oranges, that a person lost one apple, like they gained 30 oranges and they only lost one apple, they might prefer that. But we don't know that. We don't know that. But we do know that you don't necessarily prefer one or other of these. So therefore we say here, in this quadrant, right here. Say this is the dot right here. In this quadrant, right there. This is more. Right? There's no point of indifference. There's no combination here that you can be different. Right, everybody? There's no combination in there that you can be indifferent to this combination of this. Right there, that one in the corner. None of those you can be indifferent to. So they're not on an indifference curve. By similar reasoning down here, none of these you can be indifferent to. Because you have more. You prefer this to any one of these combinations. You prefer any one of these combinations to this combination. Okay? So the indifference curve number one must be negatively sloped. That makes sense. To be indifferent to another bundle, you must give up something to gain something else. Because if you don't, you'll have at least the same of one and more of the other, and you cannot be indifferent. All right. Okay, Eric, I need you. You're our guinea pig, as it turns out. Can you do it? You can do it. Okay. So now we're just going to ask Erica, as any person and anyone in the room, and I need you to do this thought experiment. Okay. I want to know, Erica, which you would prefer. How about 25 apples and 51 oranges? No, you've got a choice. I will give you 25 apples and 51 oranges, or 50 apples and 50 oranges. And you can take whichever one you want. Which do you prefer? Yeah, so it's fairly reasonable. Now, it might happen that she didn't prefer that, but we can then consider it. Usually, this is preferred. So I will say this. This is less than, right here, this is less than, like that. Okay? Now, let us assume that right here, this is 25 apples going up like this. Right? So now I'm going to jump way up here, and I'm going to say, what about if we had 25 apples and 200 oranges? Which do you prefer, Erica? This combination here, or this combination here? You still prefer the 50-50? Okay, fair enough. How about 1,000 oranges? Which do you prefer? Now remember all the wonderful things you can do in the morning. You can throw them at people. You can just imagine, just take it in your house and slice them open in your house and smell wonderfully for several days. Which do you prefer, 50, 50, or 1,000? Sorry we picked you, guys. Okay, then, we'll deal with you. How about 10,000? You can build a house with 10,000. Which do you prefer? Huh? Okay, good. Okay, so here we are. Now, it turns out we now know that Erica has a point of indifference somewhere, one of these combinations. This, it turns out, to cut to the chase, she prefers this to this. She prefers this to this. Now, it turns out we also found out down in the middle here somewhere, say, 25A and 1,000 oranges is less than. But somewhere in here, there's a combination. So let's go down. I'll say, well, just speed it up. I'll say, Erica, don't answer Erica. I'll answer Erica. 25 apples and 9,000 oranges. Would you prefer that to the center? Yes, I would. 25 oranges and 8. Yes, I would. 25 oranges and 5,000. Yes, I'd still prefer the 25 and 5. Then I'd say, what about 25,000 and 3,000? No, I prefer the center. So we get something like this. We end up with, say, we're getting close. Maybe I get like 25,000, 25 apples, and 4,000 oranges is preferred. And then down here, another one, somewhere in here. 25 apples and 3,500 oranges is not preferred. So we keep at this until we eventually get to the point somewhere, badgering her, she says, okay, we're now at at this point, here, 25 apples and 3,750 oranges. And she says, I am indifferent. I am indifferent. Right? I'm indifferent. I cannot make up my mind. There it is. She's indifferent, everybody. Now this turns out, you'd agree, at this point, she cannot make up her mind between 50 and 50 and 25 apples and 37 and 50 oranges. Now my question to you is, once we know that, I have a question for you. What is Erica's relationship between the center and 25 apples and 3,749 oranges? Which one does she prefer? 25 apples, 3,749 oranges, or 50 apples and 50 oranges? 50-50. Right? And you know why? Because by transitivity. She prefers 25 apples, 3,750 oranges to 25 apples, 3,749, because more is preferred to less. She's indifferent between the center and 3,750 oranges. Therefore, she prefers the center over 3,749 oranges. Everybody? We're establishing the points of indifference. And by so establishing them, we establish everything that's greater than and everything that's greater less. So now we can go through this whole exercise. We can ask her the number that corresponds to 24 apples. How many oranges? 22 apples. How many oranges? 100 apples. How many oranges? When we do that, we're going to sketch out an indifference curve that is going to look something like this. I'll get rid of this here. That will go through here, and it will look, say, in her case, it's pretty steep probably. Looks like that's it. That's one indifference curve. Now, everybody has different indifference math, but, you know, we can always find for any amount of apples and amount of oranges that gives that bundle, makes that bundle indifferent to 50-50. We can do that. And then we get all those indifference points. And we're not necessarily interested in that, but what that does tell us now is that every point above this indifference curve is preferred to any point on the indifference curve in this sense. This point here and this point here are above the indifference curve. Each of them is preferred to any point on the indifference curve because this one is more than this one. So more is preferred to less. But every point here is indifferent to this point. So this is superior, more than, preferred to any point, any point on there. So this tells us all the points up here are preferred to the points on the indifference curve, and every point on the indifference curve is preferred to the points underneath, right? So we've already divided